Namaste, and welcome back to JEE Physics with Typical Monk. This is class 34, Newton's laws of motion. Kinematics tells us how a body moves, Newton tells us why. Three short laws hold the whole of classical mechanics together. The first says, a body left alone keeps doing what it was doing, the law of inertia. The second gives the exact rule, the net force on a body equals its mass times its acceleration, F equals ma. And the third says, forces always come in pairs. Every action has an equal and opposite reaction. Master the free body diagram, resolve the forces, add in friction and the normal force, and even a block on an inclined plane becomes a clean, solvable picture. Today, the three laws, forces, friction, and the inclined plane. One idea at a time. Here is what you will master today. First, the three laws of motion. Second, force, mass, and acceleration. Third, free body diagrams. Fourth, friction and the normal force. And fifth, the inclined plane. One idea at a time. Let us set the foundation. A force, a push or a pull that changes a body's motion. The three laws, inertia, F equals ma, and action and reaction. The free body diagram. Draw every force on the body, then add them. Mass aligned, resolve the forces, and the motion follows. Now look at the picture. The free body diagram. The first law. A body stays at rest or in uniform motion unless a net force acts. The second law. The net force equals mass times acceleration, F equals ma. The diagram. Draw every force acting on the body and add them as vectors. The net force. Its direction is the direction of the acceleration. Now the three laws, one by one. The first law. Inertia, a body keeps its state unless a net force acts. The second law. Net force equals mass times acceleration, F equals ma. The third law. Every action has an equal and opposite reaction. Momentum. Force is the rate of change of momentum. Now force and momentum. Linear momentum, P equals mb, mass times velocity. Impulse, force times time equals the change in momentum. Conservation, with no external force, the total momentum is conserved. The second law, truly, F equals the rate of change of momentum. Action and reaction. The pair acts on two different bodies. Now look at the picture, the inclined plane. And the protrees resolve the weight into mg sine theta along the slope and mg cosine theta into it. The normal force, N equals mg cosine theta perpendicular to the surface. Down the slope, mg sine theta drives the block, friction opposes it. Friction. The maximum static friction is mu times n. Now friction and the normal force. Friction, a force that opposes relative motion between surfaces. Static friction, it adjusts up to a maximum of mu s times n. Kinetic friction, once sliding, F equals mu k times n, roughly constant. The normal force, on a level floor N equals mg, on an incline N equals mg cosine theta. Static friction is usually greater than kinetic friction. Now, three quick applications. Centripetal force, a force to the center, mv squared over r, keeps a body in a circle. Tension, in a string over a pulley, the tension links two masses. Equilibrium, when the net force is zero, the body is balanced. Now, match each law to its idea. The first law goes to inertia. The second law goes to F equals ma. The third law goes to action and reaction. And friction goes to mu times n4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. The second law is F equals ma correct. Statement 2. Action and reaction act on the same body. Wrong. They act on two different bodies. Statement 3. On an incline, N equals mg cosine theta. Correct. So the answer 2 are correct. Statements 1 and 3. The trap is the same, body claim, in statement 2. Now, the two mistakes that quietly cost marks. The truth, action and reaction act on two different bodies, so they never cancel. The trap. Thinking the normal force always equals mg. On an incline, it is mg cosine theta. The second truth. Static friction can be anything up to its maximum, μs times n. The second trap. Forgetting to resolve the weight on an inclined plane. Now test yourself. Answer in your head before the reveal. That is how G-speed is built. Here we go. Question 1. The second law, F equals ma. Question 2. Action and reaction. Same body or different? Different bodies. Question 3. The normal force on an incline, mg cosine theta. Question 4. The maximum static friction, ms times n. And question 5. Linear momentum, mass times velocity. Let us gather it all in one breath. 3 laws. Inertia. F equals ma and action and reaction. Force equals the rate of change of momentum. Friction opposes motion. Its maximum is mu times n. The normal force, mg on the flat, mg cosine theta on an incline. Resolve the weight on an inclined plane. Next class, work, energy, and power. The laws of motion. 3 sentences carry the whole of mechanics. A body left alone keeps its state. That is inertia. The net force on a body equals its mass times its acceleration. That is F equals ma, and every force is met by an equal and opposite force on another body. That is action and reaction. Draw the free body diagram, and every problem becomes visible. The normal force holds a block against the surface, friction resists its sliding, and on an inclined plane, the weight splits neatly into mg sine theta. Down the slope, and mg cosine theta pressed into it. Learn to resolve. Remember that action and reaction never act on the same body, and the forces of the exam fall into line. Next class, work, energy, and power. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.